In chapters 4.4 through 4.7, in chapters 4.4 to 4.7, you kind of have a piecemeal approach to a general strategy for factoring polynomials. And they're specifically polynomials of a certain type. And those types are trinomials that take the form ax squared plus bx plus c. So this is a trinomial in standard form or in descending order, where a, b, and c are coefficients. A is not 0, but either b or c could be 0. And so we want to use the tools that we developed in in chapter 4.3 in order to develop this strategy. And the first skill is we're going to look for a GCF, a greatest common factor. And then when we're done with that, we're going to move on to one surefire way of doing it. And we're going to call that surefire way the AC method. And the AC method is based on this A here. What's the value of that A there? And what is the value of that C there? And let's see how the AC method works. We'll do that by first reviewing our strategy for multiplying binomials. So let's take a look at the binomials, and I'll continue working in this color. If I am going to multiply x plus 4 times the quantity x plus 9, let's harken back to our little area model. And here's what our area model looks like. We draw a box, and we'll make one side of the box the x plus 4. The other side of the box will make the x and the positive 9. And what we'll do is we'll divide that box into the relevant areas. So here's our x plus 9 here, and here's our x on this row plus 4 on that row. And so when I multiply x times x, I get x squared. When I multiply x times a positive 9, I get positive 9x. When I multiply now this side, x times this positive 4, I'll get a positive 4x. And then when I multiply 9 times 4, I will get a positive 36. And remember that our diagonals, our interior diagonals, are the like terms. So when I expand out x plus 4 times x plus 9, I get the quantity x squared plus 4 of something plus 9 of something. If I start with 4 and then I acquire 9 more, I have now 13 of those x's, and then my positive 36. And so what I want to do is work backward from that in order to show how to factor using the AC method. Notice that my polynomial is now in the standard form. I have an ax squared, I have a bx, and I have a c. Well, my c is 36. My b is the coefficient of x here, which is 13. What is my a? Well, there's nothing in front of the x squared. Does that mean my a is 0? Well, no, because if my a were 0, then I would have 0x squared, and then it wouldn't be a binomial term. I'm sorry, a squared term. Remember, when I don't see a number in front of a variable, I assume a 1. So there's a 1 in front of the x squared. Now the AC method tells us to multiply a times c. And I'm going to use a little tool over here. I'm going to multiply that a times c. So 1 times 36, that's a positive 36, is 36. 1 times 36 is 36. Okay. And by the AC method, I put a times c up here, and I put b down in there, and our b here is a positive 13. Now the sign of b is important, because if I factor 36, I'll put my smaller numbers over here on the left, my bigger numbers over here on the right. So 36 is 1 times 36. It's 2 times 18. it's 3 times 12, it's 4 times 9, and it's 6 times 6. Now, what I do with my factors is I scrutinize them. I take a look and I see, well, if I have two numbers that multiply to be 36, they should also combine. I should be able to add them to be that 13. And the signs are important because the sign of the bottom number, the sign of your b term, tells you the sign of your bigger number. So these are positive. This b is positive. So that means all my bigger numbers are positive. And then the sign of the AC term tells you if these are the same as those or if these are different from your big numbers. Now, since this is positive, then they have to be the same because a positive times a positive is a positive. So all of these are also positive. Now I have to look and ask myself, can I combine any of these numbers and get a positive 13? Well, 1 plus 36 is 37, so that's a no-go. 2 plus 18 is 20. 3 plus 12 is 15. And lo and behold, guess what? We already knew it. It was up here. But 4, positive 4, plus a positive 9 is in fact 13. And here's where our area model comes back into play. Let's take a look at how this works. What I'll do, we'll do it two ways. We'll do it one way with the area model. We'll label this one the area model. And then over here we'll do it by grouping. And you decide which one you like best. I used to like by grouping. That used to be my favorite until I got a real good idea from somebody who's much more spatial than I am on how the area model works, and I kind of like the area model now. The area model is very, very elegant, very, very pretty, and very, very neat. So here's what I'm going to do. I'm going to create my area model just like I had up here. And instead of filling out the outside, I'm going to fill out the inside of the area model with my polynomial. I'm going to put my first term in this upper left corner, x squared. I'm going to put my last term in the lower right corner, positive 36. And I'm going to use these fellers here, my factors, to populate my opposite corners here, the ones that typically are our like terms. So this up here is a positive 9x, and this down here is a positive 4x. And now I use my understanding of greatest common factors to extract the factors from the area. Now, see, I know what the area is, right? I know what the area looks like. What I want to know now is what are the length and the width. So along the top row I have x squared and 9x. The greatest common factor between those two is x. And along the bottom row I have a 4x and a 36. The greatest common factor between those two is a positive 4. Going down, doing my length now, the first column is an x squared and a 4x. The greatest common factor is x there. And my second column is positive 9x and a positive 36, and the greatest common factor there is 9. So our greatest common factors tell us that our length and width, well, our width is x plus 4, and our length is x plus 9. And that's using the area model to derive the factors of this polynomial up here, of this trinomial. Let's take a look at what it looks like by grouping. So by grouping, what I'm going to do is I'm just going to rewrite this polynomial x squared plus, but now I'm going to split up 13x into those factors. So it's plus 4x plus 9x, and then 36 is left there, plus 36. Now I have four terms, and I have a greatest common factor between these two terms and a greatest common factor between these two terms. Here, that greatest common factor is x, and I'm left with x plus 4. Here, that greatest common factor is a positive 9, and I'm left with x plus 4. And from all the practice we've done factoring by grouping, you should be able to see that these two terms share an x plus 4, and when I divide that out, when I factor that out, I'm left with an x plus 9. And so that's factoring trinomials by grouping. This is factoring trinomials using an area model. And what you should see, what should become apparent, is that really they're the same thing. One is a very visual way, a very spatial way. If you like to look at things, if you're like my wife and you can pack the trunk of a car in your head before you ever put in a piece of luggage, the area model is your way to go. Or if you're like me and you look at the trunk of a car and you start stacking things in until it all fits, you're not as spatial. Maybe you're more linear and logical. This is the way to go. So whichever one appeals to you the most is what you want to use. In the next video, we're going to take a look at some more of this AC method, some more of this general strategy for factoring trinomials.